Short-run production relationships. So keeping in mind, short run is a time period in which one of our resources is fixed. So typically that's plant capacity or capital goods. So what we're interested then is when we add variable resources, in this case labor, to a fixed resource, which is plant capacity or capital goods, we want to know what's the relationship between that variable resource and our total output. So in this case, our plant produces chairs. So it's a woodworking shop. So we can hire anywhere between 0 and 8 workers. So what we're interested in now is what is the total product or total production? So if we have 0 workers, there's going to be 0 chairs built per day. If we hire 1 worker, we can produce 10 chairs per day. If we hire 2 workers, we can produce 25 chairs per day. 3 workers, it's 45. And 60, and so on. 70, 75. Now this is interesting. When we hire a 7th worker, our total chairs per day, our total product doesn't go up at all. And when we hire our 8th worker, the number of chairs we can produce in a day actually goes down. So this is all very interesting stuff. However, what we're more interested in is marginal product. So the marginal product is what is the additional output gained when we hire 1 more unit. The equation for marginal product is MP equals the change in total product divided by the change in labor. Now in our case, each unit of labor we're increasing by 1, so we don't need to worry about what's the change in labor. So what we're all interested in is what is the change in total product. So when we hire the first worker and production goes to 10, our marginal product of that first worker is 10. When we hire the second worker, the total product goes to 25, so the marginal product of that second worker is now 15. The third worker is 20. Now this is interesting. When we hire the fourth worker, the marginal product is 15. When we hire the fifth worker, it's 10. The sixth worker, it's 5. Here, when we hire the seventh worker, there's no marginal product. And when we hire the 8th worker, we actually have negative marginal product. So a couple of things to note here. So we can see that as marginal product, when it becomes 0, the total product is at its maximum. And when marginal product becomes negative, total product gets smaller. So now let's look at average product. So average product is your typical productivity measure. So average product, denoted by AP, is our total product divided by our total labor. So it gives us an average number of chairs per day. Our 1 worker produces 10 chairs, so that's 10 chairs per day. Our second worker, we have a total of 25. So we've got 25 is our TP divided by 2. So this equals 12.5. So 3 workers, we've got 45 chairs total divided by 3 workers. This equals 15. And we can go down the line calculating these. So 60 divided by 4 is 15. And then we see that the average product begins to drop 14, 12.5, 10.71, and 8.75. So what's interesting here is we can see a bit of a relationship between average product and marginal product. And what we find is that average product increases until it reaches marginal product. So at this point where average product is 15 and marginal product is 15, now average product begins to decline. That's the relationship between average product and marginal product, is average product increases until it equals marginal product, and at which case after that average product declines. So now you can see the relationship between labor and total product, marginal product, and average product. So the question becomes, how much labor should we hire? Now to fully answer this question, we need to look at costs. At first glance you'd think, well, you may want to hire 3 because when you hire your 4th worker, you're not getting as much as your last worker. That may be the case, may not be the case. The piece that's missing is our costs. and then our revenue per chair, which we'll get to in next lecture.